Hi everyone. Through this class, we are going to study about the working of demultiplexer. A demultiplexer is a combinational logic circuit designed to deliver multiple outputs from a single input. It is also known as a data distributor or Demux. The multiplexer converts a serial data signal at the input to a parallel data at its output lines. Figure shows the logic symbol of 1 to 4 demultiplexer. Here there is only one data input line, that is E, and there are two data select lines S0 and S1. Here in this 1 to 4 demultiplexer, there are four data output lines. They are D0, D1, D2 and D3. When S0 and S1 are 0, 0, then the input given at E will appear at this data output D0. If S1 is 0 and S0 1, then the data output selected will be D1. If S1 is 1 and S0 is 0, E will appear through this D2. And S1 if it is 1 and S0 1, then E will flow through this data output D3 line. The logic diagram of 1 to 4 demultiplexer is like this. Here there are 4 AND gates. And all these AND gates are connected to data input E. And there are two data select inputs S1 and S0. S1 is connected to a NOT gate. So here we get S1 bar. And S0 is also connected to another NOT gate. So here we get S0 bar. And in first case, when S1 and S0 are zeros, here we get 1 and 1. So these 1 and 1, they are connected to first AND gate. And here we can see that third input is E. So if E is 0, then the output of first AND gate will be 0. If E is 1, then all the inputs are 1. So the output D0 is 1. So if S0 and S1 are zeros, then E will appear at this D0. When S1 is 0 and S0 1, then we can see that here the E value will appear at this D1 because here it is 1. S1 when it is 0, here it is 1. And S0 if it is 1, then two inputs are 1 and 1. Then third input will appear at this D1. The next possibility, when S1 is 1 and S0 is 0, then we can see that here this is 1 and this S0 is 0. So here it is 1. So two inputs are 1 and 1. So this E will appear at this D2. When S1 and S0 are 1, then this E will appear at this D3. The logic symbol of 1 to 8 demultiplexer is shown in this figure. Here there is only one data input line, that is E line as before. But here there are three data select inputs S0, S1 and S2. And there are 8 data output lines D0, D1, D2, D3, D4, D5, D6 and D7. If S2, S1, S0 are 0, 0, 0, data output selected is D0. If it is 0, 0, 1, data output selected is D1. If S2, S1, S0 are 0, 1, 0, then output selected is D2. If it is 0, 1, 1, output selected is D3. And if it is 1, 0, 0, output selected is D4. If it is 1, 0, 1, output selected is D5. If it is 1, 1, 0, it is D6. And if the inputs are 1, 1, 1, output selected is D7. The logic diagram of 1 to 8 demultiplexer is like this. Here there are 8 AND gates and 3 data select lines S2, S1, S0 and only one data input line E. All the AND gates, they are connected to this E line. Then the output lines are D0, D1, D2, D3 up to this D7. When the input select lines S2, S1, S0 are zeros, here the output of this NOT gate is 1. Here also this is 1. This is also 1. All these three ones are connected to this AND gate, first AND gate. And it is also connected to this E line. So this E will appear at this D0. If it is 0, 0, 1, then the output will appear through this D1. So in this manner, if the S2, S1, S0 are 1 and this E line is applied to this last AND gate also, then this E will appear at this D7. If we want to construct 1 to 16 demultiplexer, then we need 16 number of AND gates like this. And in that case, we need 4 data select lines. They are S3, S2, S1 and S0. And here we can see 16 number of output lines D0, D1 up to D15.